Good afternoon, everybody. My name is Paul Vincent Pignotti, and today I'll be talking about how scientists found that narwhal tusks have been showing an increase in mercury levels and exposure to the narwhals and how it's related to climate change. This comes from ScienceDaily.com. This was published on the 29th of March, 2021, and the study comes from McGill University and their team of international scientists and researchers. All credit goes to them. And that being said, let's get started, okay? All right, so first we're going to talk about the contents of my presentation. What was found in the study? We're going to go over that. And then we're going to dive deeper into that when I divide them into subtopics of 3 separate slides: habitat changes, dietary changes, and pollution exposure. And then we're going to talk about why you should care about the narwhals, because why should you care about the narwhals? They're all the way in the Arctic and they're just having mercury. Why does that affect you? We'll talk about that. And then I have a few questions for you. And with that being said, let's get started. Oops, there we go. All right, the results of the study. So that study found that when they were comparing tusk samples from narwhals from all the way back in 1960 to today, they found that there was an increase in mercury levels. Well, why were they able to tell this through the tusk? Well, the tusk, think of it like a tooth on a human, it's a bone, right? But it has its own blood supply, it's fed by the body, and any changes in body chemistry will be reflected in the tooth. They can see that. So the tusk is just like that. It has its own blood supply, and you're able to see what's happening through looking at the tusk. And we're going to talk about changes in behaviors due to climate change and mainly habitat destruction from climate change. So what is this climate change habitat destruction that's going on? Well, it's actually sea ice loss, and we'll go into that now with habitat changes. The sea ice loss is the big one. This is probably the root of most of the problems. It is the root of it, and it's because, well, it diminishes where they live, and they rely on that sea ice because their prey normally relied on that sea ice. And we'll talk about dietary changes in the next slide. But also, sea ice has been on the decline since 1990, ever since then. And the lack of sea ice and warmer temperatures have invited enemies of the narwhal, like orcas. They have started competing, and they have started taking over places where narwhals used to live. And so that's dangerous for the narwhal. So they're just being impacted like that. Also, the sea ice is important in filtering out environmental mercury because mercury is all around us, but it gets filtered out, so it's safe. However, in the Arctic, all they really have is that sea ice. So that sea ice usually absorbs it, but it's not as much as there to absorb it. So it makes the problem worse. It makes the problem worse. So yeah, that's a big issue. And if you look at this right here, you see that there is a decline as compared to the 80s, 90s, and all the way down. You're going to see that as of March 29th, so past week, we're right here. We're at a low level of sea ice right now. So, yep, it's very important. Sea ice is very important to the mercury cycle when it gets cycled out, and that's just not there right now, or as much numbers. All right, so dietary changes. We're going to talk about the dietary changes, and it's caused a lot by the sea ice, and it does impact the mercury exposure because before, the narwhals were eating things like halibut and they were eating Arctic cod. That does not have a lot of mercury in it. However, that changes when they decided to switch to open water prey sometime after 1990, which was when the sea ice started becoming a big issue in the 1990s. After 1990s, they actually started switching because sea ice was declining, and that was reflected through dietary changes. And they started eating things like capelin. It's a little silverfish, which a higher mercury content. So it exposes them to more mercury, and that's reflected in tusk. However, it's not the biggest issue. It's not the big one. So the sea ice that the halibut and Arctic cod relied on, it went away. So they changed their diet, and they started changing, and it is not the main issue. That's important to keep in mind because the main issue is pollution exposure. So now we have a much bigger concentration of mercury because there's more pollutants in the air and there's more emissions. So the higher level mercuries have been discovered in the narwhal tusk. That is the overarching thing of this presentation. And the scientists concluded that this spike in mercury in the narwhal tusk, when they're looking at it, happened sometime like 2000 or so, which also correlates with sea ice being gone for a period of time, environmental process of filtering it out, remember? And then, so now that introduction of more heavy metals comes from the burning of fossil fuels, and they were able to trace it back to Southeast Asia in this study. And you can actually see how it happens in this separate figure right here. I didn't get it from the article. But you see it travels over air, the emissions and the heavy metals and stuff, and through the ocean currents, rivers, and it goes into precipitation or directly into there, and it usually deposits into ice. Well, now we're seeing a spike in fossil fuel use, and there's not as much ice. So that is how climate change really impacts that right there. So mercury can lead to many ill effects on the narwhal, so like reproductive health harm, and then we're going to see some cognitive function being affected negatively. And it's important to note that mercury biomagnifies. So mercury kind of makes its way up the food chain, and it gets worse and worse as you go up the food chain, because the top of the food chain, like narwhals, they eat the lower things which have mercury, and then as it goes up, it magnifies into the next chain of the food web, and then the next one, and it all accumulates into the apex predator. And so it is certainly affecting the narwhals heavily here. So now, why should you care? Why should you care that narwhals in the Arctic, thousands of miles away, are negatively impacted by this? Well, because mercury levels in our oceans impact us all, because there are many fisheries in the Arctic. Like the Alaskan pollock you eat when you eat a fillet of fish, that's Arctic. That's from the Arctic. The halibut, we all like, if you eat seafood, the halibut's a really good option. It's tasty, but it's from the Arctic. It's from the Arctic Circle. And cod, like in fish and chips, that's from the Arctic. So it's important to note that we need to be really careful with what we're doing to our ecosystems and what we're burning into the air, causing more mercury. Because mercury poisoning, the way it affects narwhals, it affects us as well. Reproductive health, mental disease, it's bad. It's bad. And we need to be careful because it's already taking impact on our coasts. In Southern California, as a fisherman, I know there are guidelines where you're not supposed to eat fish you catch from the coast. You're not supposed to eat more than 2 servings a week. And then in places like in places like around LA, that's actually called the red zone, where you're not supposed to eat much fish, maybe 1 serving a week or none at all from that area. So it impacts us all. We don't want that to start impacting the global economy, because the Arctic is such a big production of fisheries. So now, when did sea ice loss become prominent? Okay. Was it after 2001, after the 1960s, after 1990, after the 1980s, or the 1980s, or 1975? Second question, what prey did the narwhal switch to? Did they switch to open water species, or did they go for the bottom dwelling species? Did they start scavenging, or did they start eating the vulnerable penguin chicks that definitely live in the Arctic, right? And then, or did they start going for tuna and other big game? All right, those are my questions. And fin, or since we're talking about narwhals, fin. Thank you very much, guys, and have a great day.